All right, so, ooh, that's hot. In this video, we're going to look at the polyatomic ions, the diatomic molecules, and a few other just side things about naming, okay? Now, it's really important that you memorize the polyatomic ions, okay? There are not a lot of things in chemistry that I ask you guys to memorize, but the polyatomic ions are one of them. There are 6 polyatomic ions. I'm also going to ask you to memorize the 7 diatomic molecules. So both of those are in this lecture. All right, so let's look at the word polyatomic ion and kind of break it down. So a lot of times when covalently bonded compounds are formed, they can have a net charge. Now, think about this for a minute. I have, say, SO4. This is sulfate. Sulfate has a -2 charge overall, which means as a molecule, right, this is what sulfate looks like. It's a Lewis diagram, and we'll learn more about Lewis diagrams when we do bonding soon. On this molecule, overall, there is a -2 charge. So that means even though this is not an ionic compound, it acts like an ion. It has this -2 charge. So we call those the polyatomic ions. They're ions made of multiple atoms, and you need to memorize these 6. All right, we're going to use a bunch of them, but these are the 6 that you need to know. I strongly recommend, that you make flashcards in order to do this. And their naming rules are actually really similar to the ionic compounds. So here are the 6 that you need to memorize. Ammonium is NH4 plus 1. Hydroxide is OH minus 1. Nitrate is NO3 minus 1. Carbonate is CO3 minus 2. Sulfate is SO4 minus 2. And phosphate is PO4 minus 3. Now, I've organized them here in such a way that maybe it will help you learn them, okay? There's only one plus 1, all right, species, right, the ammonium species. There's only one minus 3, all right? There's 2 minus 1s, and there are 2 minus 2s, okay? The endings are important. These 8s, right, APE here, that actually means something that we'll learn about later, as does the ide, which we already know about, right? It tells you it's binary. It tells you that it's hydrogen by itself there, and oxygen by itself, and you have ammonium, which is an ending that's a common ending. Now, when we use them, all right, you never, ever, ever change the name of a polyatomic ion. So like before, we were changing the endings of our anions to IDE. You don't do that to polyatomic ions. You just write them. You still use the cross-charge method when they're, bonded to a metal or non-metal. You still use the stock system if you need to, if there is a Roman numeral. You never, ever, ever use prefixes because they're ions. They're an ionic bond. So let's name a couple of these. All right. So NH4 and O3. All right. Well, the metal here, remember metals are the cations. The metal here is ammonium. It's a +1 charge. And nitrate has a -1 charge. So I write the metal, I write the non-metal, and since the non-metal in this case is a polyatomic ion, I don't change it. This is just ammonium nitrate. All right, here I have NH4 2O. Well, I write the metal. In this case, my metal is ammonium, but my non-metal is just oxygen. So I use the suffix system and the cross-charge method, right, to figure out I would use the cross-charge method if I was trying to write the formula, but I use the suffix method since I'm trying to write the name. So I write ammonium, and then oxygen becomes oxide. Here we have ZnCO3. So zinc is one of the transition metals that never gets a Roman numeral, right? It's always +2. Carbonate's -2. That's why there are no subscripts next to zinc. The 2's cancel out. I write the metal, zinc. I write the non-metal, which is in this case carbonate. All right, PbNO3 2. All right, this one is the first one we're going to have to kind of think about for a minute. So I know I've got lead, I know I've got nitrate, but lead's a transition metal, so I need to uncross the charges. So this 2 comes up, becomes a +2, There's nothing here, so it must be a 1. That's a -1. And this is why it's important that we've memorized our polyatomic ions. Nitrate is NO3 -1. So when I uncross the charge, it checks out. This is good. So that means that 2 is the right charge for lead. So I say lead 2 nitrate. That's my answer. Now let's go the other way. Let's write the formula. All right, lithium sulfate. All right, well, I have lithium. I have sulfate, SO4. All right, we've memorized sulfate is SO4 -2. Lithium is a group 1 metal, so it's +1. I'm going to cross my charges. 1 sulfate for every 2 lithiums, so Li2SO4. Ammonium chloride. All right, I know ammonium is NH4 +1. Chloride is chlorine. It's a halogen. It's -1. When I cross those charges, the 1s are going to cancel, so NH4Cl. Barium carbonate. All right, barium, group 2 metal, carbonate, CO3 2-. 2s are going to cancel, BaCO3. Here's a good one. Tungsten 8 phosphate. All right, tungsten symbol is actually W. The 8 tells me its charge, and phosphate is PO4 -3. So the 3 comes down, the 8 comes down. I can't reduce it, so W3, PO4, 8. And that's my answer. All right, the diatomic molecules. The diatomic molecules are molecules that exist in nature always in dimers or pairs. All right, a dimer, from biology, I hope that you know that the word mer means part. So a dimer is a 2-part. The diatomic molecules are 2-part molecules. So anytime you find hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, or iodine by themselves, then they are diatomic, okay? They are always N2 or H2 or O2 or F2 or Cl2 or Br2 or I2. You'll never find a chemical formula where it's just H by itself, unless it's an ion for, an acid-base equation, in which case you're looking at a net ionic equation, which we don't know how to do yet. So in all of our formulas and all of the writing that we're doing our chemical reactions in, if you see HNOF, ClBr, or I, there are always going to be 2 of them. Easy way to remember this, Brinkelhoff. That's what this stands, Brinkelhoff. All right? Or have no fear of ice cold beer. All right, that's one. Have no fear of ice cold beer. That's the other way you can remember it. All right. I think Brinkelhoff sticks on the brain better, but that's just me. Now, when we name our diatomic gases, okay, you use the word molecular in front of them. That indicates it's a molecule, not an atom. So N2, you would say molecular nitrogen. H2 would be molecular hydrogen, etc. Okay. Now, the only way to get good at this stuff is to practice. So go name stuff. All right. There's lots of stuff for you guys to name. There are plenty of things in the book if you need a couple extra things to practice. If you have questions, all right, please ask. All right, I'm here to help you guys. Okay, so that's it for polyatomic ions and Brinkelhoff. Make sure you memorize the polyatomic ions. Name, formula, charge. All right, you should be able to just spit them out. Like nitrate is NO3 -1, ammonium is NH4 +1, carbonate CO3 2-, right? You should be able to split those out. Make flashcards if you need them.